Hello everybody, it's time for another video. Today we are going to learn all about division properties of exponents. In other words, by the end of this video, you're going to look at problems like these and think they're a joke. Here we go. Okay, so we're learning division properties of exponents. The first thing that we're going to start with is something called quotient of powers. Now, remember, the word quotient means the answer to a division problem. So what the quotient of powers says is that to divide powers with the same base, all you have to do is subtract the exponents. So you're going to take the exponent from the numerator, that's the top one, minus the exponent from the denominator, that's the bottom one, as long as you have the same base. Let's take a look at what this looks like. Okay, so we've got three problems here. The first one, c to the 11th over c to the 8th. When I go to solve this, they have the same base, so just subtract the exponents, top minus bottom. So I have 11 minus 8. And 11 minus 8 is 3, so that means this is going to be c to the third power. Right here, r to the 5th over r to the 2nd. Again, they have the same base. Top exponent minus bottom, 5 minus 2 is 3, so we have r to the third. Next, a to the third over b to the second. Do these ones have the same base? No, they do not. So you can't do this. We're literally just going to write a to the third over b to the second. We can't take it any further. Why is that? It's because the bases are different. So let's take a look at one a little bit more complicated. I've got x to the third q to the 5th over x q to the third. Well, for the x's, I've got the same base on top and bottom. So x to the 3 minus, and do you remember what exponent goes there? If there's nothing written, it's a 1. 3 minus 1. And then for the q's, 5 minus 3. 3 minus 1 is going to be 2. And 5 minus 3 is going to be 2. Make sense? So the next part we're going to go over is a part called powers of a quotient. And we actually hit this on the last section, but it's in this section as well for our text, so I'm going to go over it again. There's no hurt in going over something twice. So what you need to know here is if you have a quotient or a fraction and you have an exponent on the entire thing, well, what's going to happen is this exponent is going to multiply by the exponents on the numerator and denominator on every single part of it. So here, you can see how there's no exponents written. So again, we fill in a 1 for both numerator and denominator. And we end up with 1 times 2, which is 2. So I have 3 to the second power. Here, 2 times 1, which is 2. So I have x to the second power. Now, the x to the second power, since I don't know what x is, I have to leave that alone. But for the numerator, 3 squared, I know that's 9. So this becomes 9 over x squared. Once you're shown how to do these style problems, it's really hard to make them difficult. But I suppose we can try. Maybe I'll throw a negative in here too. So I've got negative 3x cubed over 7. And all of that is squared. So again, if you don't see an exponent on something, you can put a 1. So now it's negative 3 to the first power, x to the third power, divided by 7 to the first power. So I'm going to distribute this, multiply all these exponents. So I get negative 3 to 1 times 2, which is 2, power, x to the 3 times 2, which is 6 power, over 7 to the, and 1 times 2 is second power. Now, negative 3 squared, I've got 3 times 3, which is going to be 9. And since my exponent was even, that means it's going to be positive now. If this was an odd number like 3, I'd put a negative sign here. Remember that from last video? X to the 6th power, I don't know what x is, so I just leave that alone. 7 squared, that's going to be 49. So that's not so bad. So the next thing that we're going to talk about is something called zero exponents. Zero exponents are super simple because anytime you see an exponent of 0, then the whole thing, base exponent, everything equals 1. Let me show you. So let's take a look at these two examples here. Here I've got r to the 0 power. Again, anytime something has an exponent of 0, it just equals 1. So that equals 1. Right here, x to the third over x to the third. Now remember, when you have the same base in numerator and denominator, I told you to subtract the exponents. So top minus bottom, 3 minus 3, and 3 minus 3 of course is 0. X to the 0 power equals 1. Done. Nice and easy, right? Now some of you may be curious and asking yourselves, why is that? Well, if I put 2 over 2, you would agree that 2 over 2 equals 1, right? What if I put x over x? Same thing, top and bottom. That equals 1 because 2 can divide into 2 one time, x divides into x one time. Well, what if I put something like this? X over x squared. Well, we know that would be x squared over x squared, right? Next, what's x squared mean? Well, it means x times x. And again, same thing on bottom. Now, we already talked about this here. If I had x over x, that would equal 1. So if I cover this up, I end up with x over x. So in other words, these two cancel out, they equal 1. Right here, the same thing happens. X over x equals 1. What's 1 times 1? 1. So in other words, this whole heap equals 1. If you don't want to memorize the reason why, that's okay. You don't have to, although I really like you to understand it. Just know that anytime you end up with an exponent of 0, the whole entire thing, base included, equals 1. So this would equal 1. So let's take a look at 2 more problems just to really drive this point in. So right here, I've got a 2 on top and nothing that matches with it on bottom. I've got x to the third on top, nothing that matches with that on bottom. But here I have q to the third over q to the third. So what's going to happen is this. The 2 and the x to the third power, they're not going to cancel or anything. But right here, q to the third over q to the third. Well, that's going to be q to the 3 minus 3 power, and 3 minus 3 equals 0. So I get 2x cubed, q to the 0 power, and anything to the 0 power equals 1. 1 times 2x to the third power is going to be 2x to the third power. So there you go. In other words, when you see the same thing on top and bottom, you can just set it equal to 1. 1 times 2x cubed would be 2x cubed. There's your answer. Now right here, 3xy squared divided by negative 3x cubed pi. But take a look at this. All this is to the 0 power. So in other words, 1 times 0, 0. 1 times 0, 0. 2 times 0, 0. And so forth. All this would be the 0 power. Whole entire thing equals 1. So anytime you have something right here, if the whole thing's set to the 0 power, it equals 1. Done. Easy as that. So that's it for this lesson. I hope you enjoyed everything. Don't forget to hit that like and sub button. Also, if you want some extra practice on this, or you want to see some extra problems done just in case, I'm going to keep the video going for a minute or two, and I'll put some extra problems up here and solve them. If you've got this okay, I'm done though. I'm not teaching anything new from this point. Okay, so here's a couple more problems. If you can understand these, you should be pretty good to go with everything else. So here, r to the fifth over r to the third. When you have the same bases, all you do is subtract the exponents. 5 minus 3 is 2. Now, I know before when I was showing you this, I would write 5 minus 3 here and then say r to the second power is the answer. If you want to, though, you can go ahead and just skip right to the answer if it's something you can do in your head. That's fine. I was just putting that there for demonstration purposes earlier. Now, here, you can see that I have the same base here with the x's. With the numbers, I don't. Don't forget the math you already know. 2 over 4, I can reduce that fraction. That reduces to 1/2. So right away, that's going to be 1/2. That takes care of this part here. Now I have x to the third over x. If there's no exponent, that's a 1. 3 minus 1 is 2. So this is going to be x to the second power. Now, if you want to, you can simplify that. 1 times x to the second power would be x to the second power. So you can just write it like this. Right here. This is an exponent of 3. So if there's no exponent here, put a 1. Now remember, when I multiply this stuff here, it's going to work as follows. 1 times 3 is 3, and 2 times 3 is 6. I would strongly recommend that you actually do this step that I'm writing here and try not to do this all in your head. As the problems get more complicated, it might be a little bit difficult to remember what you're doing. So here, 3 to the third power. Well, 3 times 3 is 9. 9 times 3 is 27. So you know that's going to be 27, but this was a negative number. So you look here, if the exponent's even, the answer would be positive. If the exponent's odd, it's going to stay negative. And if you forgot why that is, check out the last video. Now I've got the same base on top and bottom, an x, 6 here, 6 here. 6 minus 6 is 0. Anything to the 0 power equals 1. It goes away. So there's our answer right there. This one right here, I've got this disgusting looking fraction, but speaking of 0 exponents, anything to the 0 power equals 1. So we're done. If you've got that, you should be set for this lesson. All right, see you later.